Welcome. Hello. My name is Will, and I love science. I'm here to share some of CK-12 science resources with you and a little experiment that you can do on your own at home in these weird times where we can't really access our lovely lab facilities that we all totally have. So to me, science is something that I love studying it. It's an amazing way to ask questions about the universe and get information that lets us do amazing things like talk to each other miles apart, separate but together, and share knowledge like this. Today I want to talk about solutes and solvents. So to start, you might be asking, what is a solute and what is a solvent? So let's get started. But first, every experiment, you need personal protective equipment. So solutes are compounds that dissolve in other compounds. So in this case, our solute is going to be salt. Might be a little hard to read, apologize. Everyone's favorite solute. It's salty, it's white, looks great, tastes great, and it dissolves really well in in quite a few substances, especially water, which will be our solvent in this case. Solutes and solvents combine together to make solutions. Solutions are a very important fundamental part of chemistry, biology, even to some extent physics. Studying how solutions work can be a physics problem. Most solutions we see on a daily basis are solutions in a solid and a liquid. Because our planet is covered in water, there's tons of water everywhere, usually the solvent's water. In fact, in our case, as cellular organisms made of cells, our main solvent is water in our cells. We use that to move the parts of our cells around and keep our cells moving, which is why you've got to stay hydrated. But other kinds of solutions exist too. You can have solutions of solids where you can have like a metal dissolved in a metal to make an alloy. That's a solution of a solid. Even gaseous solutions exist. In fact, I know I said the most common solution is, would be something dissolved in water, but in fact, we're always breathing in a solution of gases, the different gases in the atmosphere into our bodies so that we can breathe and pull the oxygen out of it and live. It's a great thing living. But today I want to do an experiment about I want to show a little experiment about how solutes dissolve in solvents. So the rate at which something dissolves can be affected by several factors. So we're going to look at a few of those factors. I've got two different kinds of salt in my lovely test tubes here. This is a much more coarse salt. It's got much less surface area. So you can think of like more of the salt is trapped up inside of all the salt in there. And that makes it harder for the solvent to access. Whereas in this tube, I have a much finer salt. This is probably what you think of more as table salt to season your food with, what have you. And then you may have noticed I've got these lovely letters written on my test tubes. It's very important to label your test tubes so you know what's in them. So we're going to be using two different temperatures of water. I have some water here that is about 20, very difficult to read, 20 or so degrees Celsius. And I have some water here, which you have to trust me on this one. It'll take too long for the thermometer to reread, but this is at about 10 to 12 degrees. So we've got about a 10-degree difference in water temperature. And we're going to add this water to these test tubes and see which of these will dissolve the fastest. So we're going to talk about dissolving a little bit and then come back and see how much of each one has dissolved in the meantime. But first, before you pour any kind of liquid, even water, you need goggles. They're very important. Personal protective equipment is the most important thing when doing lab experiments. Always be safe because it's really better than being sorry. So let's add our solvents to our solutes. So we have our warm water. I'm going to add this first to our coarser salt. And I'm using the same volume. I've just indicated, kind of pre-measured these earlier, so I know how much I'm adding to each one. I'm not going to shake these. We are just going to let them sit and see what happens. This is our other warm water treatment. I know I said H for hot, but we don't really want to be doing anything too crazy with hot water that could burn us. You know, I prefer safe science whenever possible. All right, and then we're going to switch to our cold water. So here we have colder water going into our coarser salt. Whoa, can I get that back in? Yes. All right. And then we're going to add cold water to our finer salt. Okay, as I said, I'm not going to mix these. We're going to see what happens. So we can already take a quick peek and just look at the level of the salt in there to kind of see relatively how much has dissolved. I know I gave it away a little bit already, but we will come back to that in a sec. So now that we're done doing the setup of the science is always happening, but we've just finished setting it up for the time being. Let's look at a couple of the factors that affect how solutes dissolve in solvents. So let's jump over to CK-12, everyone's favorite place to learn. There we go. Okay. So cool. So let's look at our content about rate of dissolving. So the rate at which a solute dissolves in a solvent kind of determines how long it takes for that solvent to interact with the solute. So, you know, the solvent in the case of water is a really small molecule. It's super tiny. It's about, well, it is about 18 atomic units per molecule. Its molecular weight is 18. It's very small compared to just about everything else, including sodium and chloride. It's way smaller than both of those. Well, actually, about the same scale as sodium. So what we're looking at when something dissolves is how quickly, or the rate of dissolving is how quickly does that substance get into how quickly can the solvent get into the solute, because it's got to get in there and break it up and, you know, move the molecules out and spread them out into the solution so then it can become a homogeneous solution. So we've got a couple factors that affect our rate of dissolving. So there's surface area. We're looking at that right now in our experiment with, you know, how coarse or fine the salt is. Agitation, which is why I said I was not agitating this. So we're not looking at agitation right now, but you can try that on your own at home. And temperature, we're also looking at temperature. So we're going to see will more kinetic energy, so temperature is kinetic energy in the solvent, in this case, is that going to increase or decrease the rate of dissolving? So we will take a look at that. Well, we'll take a look at the results in a second. We'll see if we can draw some conclusions. In the meantime, let's take a look at a little animation. We've got some great simulations at CK-12, especially some of the chemistry ones are my favorites. Let's take a look. You can get here from our lovely Explore tab. My favorite because it's just closer. And we'll take a look at our simulations real quick. So let's jump over to our chemistry simulations. And we're going to go down to the salty roads simulation. So this simulation talks about colligative properties. When you dissolve solutes in solutions, it often changes the property of that solution because now you're looking at something that's kind of like more in between the two. So, you know, many counties, cities, states will use ice or salt in the winter to help melt ice and keep roads clear of ice. I encourage you all to check out the simulation and watch this on your own later. For now, let's just jump to the part that's interesting. So we have this lovely animation of how solvents dissolve solutes. So in this case, we can choose, sorry, for the simulation, we can choose different amounts of solute to add to this piece of ice, and we can choose different types of solute. I encourage you, again, to explore the simulation and figure out why those factors matter and what they change. We've got a great graph down at the bottom to help you correlate your findings and see how the colligative properties affect, or how water is affected by colligative properties. So if we start the animation, we're going to see, we're looking at our sheet of ice that's made of water molecules all fixed in one place. And we're going to see our solute, which is salt. It's a nice little crystal, cubic crystal structure. You've got the green chlorine ions and the purple sodium ions in there. And you can see how the water molecules kind of work their way into that crystal of salt to dissolve it and incorporate it into the rest of the water. And here we're showing the ice melting because it's incorporating the ice into itself, and it's actually changing the point at which it would normally freeze, which is a colligative property, freezing point depression. So yeah, that's just one example of how solutes, a solute will dissolve in a solvent. And I definitely encourage all of you to take a look at the simulation and see what you can gather from it. I think it's a great way to explore colligative properties and electrolytes. One last thing before we go, we can look at our lovely molecule explorer and take a look at the crystal structure and the structure of sodium and chlorine, which another great feature. So let's see. So, all right, let's go back to our rate of dissolving content. So we're looking at surface area, and let's maybe even take a look at our test tubes now. So you can jump back to me and let's see where we are at. So we've got our warm water with coarser salt. Let's compare that to our cold water with coarser salt. I don't see a great deal of difference. They look to be at about the same place. You can see there's, if you look very closely in there, you can see there's some bubbles coming out of the salt, which to me says that it is in the process of dissolving. It's doing it very slowly. Let's compare our finer salt. So, need a better test tube rack. Okay. So, in the amount of time we've had, not a whole lot has changed, admittedly. It's a pretty negligible or minor difference, but you can see a little bit more of the salt, the finer salt that was put under hot water has dissolved than the fine salt that was put under cold water. So to me, this suggests that temperature does indeed have a big effect on how solutes dissolve in solvents. Now, we often explain this as, there's more molecular motion in a warmer liquid. The feeling of temperature that you feel on your skin is actually the feeling of billions, trillions of tiny molecules smashing into your hand and your hand going, ow, stop it, as that's happening. And that's a sensation of heat. And so, those billions of trillions of tiny molecules crashing around, it kind of helps to get that solute into solution too. They're crashing into the salt crystals. They're trying to knock more of those ions out of the crystal structure and back into the solution. And so heat is a big factor in increasing the rate of dissolving of solution. We also can see from our surface area experiment that, even though the finer salt dissolved a little bit quicker in the warm water, we really don't see much of a difference here when we're looking at our larger crystals, which maybe could mean that surface area also plays a big factor in how quickly something will dissolve. Now, we're not going to shake these, but if we did, we would probably see a pretty dramatic change in how fast they start dissolving. So that has been our your daily dose of science. Feel free to try this experiment at home. I encourage everyone to take a look at our rates of dissolving content. Also, the salty road simulation is a lovely simulation by CK-12. And I hope you guys are all doing great out there. Stay healthy, stay indoors, and keep thinking about science. Bye.